is not going to be 1. So now, with these equations, we start by multiplying to get rid of all the denominators. So for the first one, we would have to multiply by 2, and if you take it to 1, watch it, you take it to every single piece. And for the second fraction, we would need an x minus 1. So everything gets both a 2 and an x minus 1. Right. From there, we start canceling things. So if you have 2 on top and bottom, it drops. The x minus 1 drops here, nothing on that one. So we have 2x minus 3 times the x minus 1. We have 2x times a 2. And we have x times that, or 2x minus 2. If you want to go ahead and distribute that piece. Is everybody with me here? So now we can multiply this out. So we get 2x squared minus 2x and minus 3x would make a minus 5x plus 3. This one is just a 4x, and over here we get 2x squared minus 2x. What now?
Simplify.
Right, we need to start combining like terms so we can simplify all of this. So we can combine the negative 5x and the 4x. If you subtract over the 2x squared, those cancel. We add over this x, we get 3 equals negative x. So my final answer, x is negative 3. Well, I added my x, so negative 2x plus 1x. Other questions? Is that an okay answer? Yeah, we said at the beginning that x couldn't be 1, so negative 3 is fine. What if x couldn't be negative 3? What would our answer be at that point?
No solution.
No solution. All right. So that's an equation. I want to do another one. So where do we begin here? Factor. So that would factor into x plus 7, x plus 2. So what can x not be? So now to start canceling things. We have to multiply by x plus 2 for the first fraction. And that cancels part of our denominators. The other thing we need is an x plus 7. So that leaves us with 1 times x plus 7, 3 times x plus 2, and a 5. Y is equals negative 8 and x is negative 2. What does that mean? No solution, because we said x can't be negative 2. Alright, I want you guys to try the next one. So, what can x not be? I saw 2 different approaches on this. So if you want to cancel an x squared, you can multiply by x squared to everything. And if you do that, x squared does cancel an x. You would have x squared minus 3x minus 10. Some people also multiplied by the plain x, which is fine. If you did that, you would have x cubed minus 3x squared minus 10x equals 0.
I was sitting here trying to confuse me when I did that.
If you did that approach, what do you have to do first here?
After that, yes.
Okay, and then at that point, on both of them, this factors into x minus 5, x plus 2. So if you did the first one, you only get 5 and negative 2 as solutions. If you did the second one, you get 0, 5, and negative 2. Why are both of these okay? We know x can't be 0, so if you did that at the end, you would mark that off, and then you get your 5 and negative 2. So either of those is fine. Alright, are we good with the equations? Okay, let's recap inequalities. So with inequalities, it's a different approach because you can't multiply by anything with an x in it. Because if it were negative, it would flip the inequality. If it's positive, it doesn't. And we don't know if x is positive or negative. So instead, we try to get everything on one side and 0 on the other. Then we need a single fraction. So we have to get a common denominator. This is like 1 over 1. So you would have to multiply it by 2x plus 1 on top and bottom. If you want to subtract that, what do we need to do first?
Change negative to a positive.
So x squared and negative 2x, or sorry, x and negative 2x is negative x. 2 and negative 1 is a positive 1. And so then we have to figure out what makes the top equal 0 and what makes the bottom equal 0. Because those are the x-intercepts and vertical asymptotes, which is where we can switch signs. So we get x to be a negative 1, sorry, not a negative 1, positive 1, and a negative 1/2. And then what did we do? Yeah, we made the sign line. So we put those points, and then we did test points for each interval. And we are plugging those test points into our inequality here. And we don't even care what number it equals, just if it's positive or negative. So if we put in a negative 1, you get a positive over a negative, which is negative. Put in a 0, you get a positive over positive, which is positive. Put in a 2, you get a negative over positive, which is negative. Okay, so our solution, we wanted less than, so that's negatives. Equal to means bracket, but can both of those get a bracket? Which one cannot? Right, so it would be negative infinity to negative 1/2. That's the denominator, so it's a parenthesis. Union bracket 1 to infinity. Let's look at another one together. Actually, you guys do the next one. We'll look at the last one together. So we have a fraction on one side, 0 on the other, so set top and bottom to 0. So we get 0 and 2. So if we do our sign line, smaller in between and bigger. Put in negative 1, you get a positive over a negative. So that's negative. Put in a 1, you also get a positive over a negative, which is still negative. Put in 3, get positive or positive, which is positive. Greater than 0 means positives. No equal to, so just parentheses to infinity. It looks like we did pretty well on that one. Last one. What do we do here? Get it all on one side. Okay, we need a common denominator, so you have to take the first one times x minus 2. You take it times what it doesn't have, and the second one just gets the x. So we get x minus 2 over x times x minus 2 minus x over x times x minus 2. X and negative x cancel, so this gives us negative 2 over x times x minus 2. What makes the top 0? Nothing. What about the bottom? So we have those 2 points to check. So same process, we just had to work with getting the common denominator on both terms. No, because I brought everything over to the left. So test points. And we are plugging those in right here. So the top is negative no matter what. On the bottom, I would have a negative times a negative, which is positive. So overall, that section turns out negative. If I put in a 1, I have on the bottom a positive times a negative, which is negative. Negative divided by negative, it's positive. If I put in a 3, on the bottom I have positive times positive, so we get a negative overall. Which ones do we want? Negatives. No equal to, so we don't have to worry, but it couldn't be 0 and 2 anyway, because they're both from the denominator. And that is our final result. Are there any questions? So at this point there is a handout on Google Classroom, which is practice for both of these. And we've got the rest of the hour to work